So we're gonna talk about motivation and emotion now. Did you guys ever watch that movie Free Solo about Alex Honnold? He's a American rock climber who was born right here in Sacramento, California, went to Mira Loma High School, became probably the most famous rock climber in the world after his 2018 documentary film Free Solo about the time he climbed the face of El Capitan with no safety gear. If you think about what he was doing, there's no way to rationalize that it was a smart, safe, logical thing to do. Yet he was so passionate about climbing El Capitan without safety gear, he was willing to risk his life for it. You have to wonder, what's his motivation? Traditional motivations didn't seem to bother him, right? He had a different set of motivations that were driving him. We look at people like Alex and we think they're not like us, and they're not. But their drive system, their motivation system is just like ours. It's just that they have different experiences, unique sets of circumstances, and they have prepared themselves differently for it. Motivation is difficult to understand in people until we know what everybody comes with in terms of the biological imperatives that we all must fulfill. So what do people mostly share in common about their needs? There's this theory called arousal theory, and arousal theory basically states that we seek out the perfect level of arousal for us. It makes a lot of sense in that my level of arousal is nowhere near Alex Honnold's. Anyway, the rock climber guy, nowhere near. He has some needs for arousal that are far beyond mine. That's terrifying to me. I don't even like hot air balloons. There's another theory called drive reduction theory that basically states you have physiological needs: water, food, shelter, sleep, and you seek those out in order to reduce your drive to do that. So you have this drive for something, right? You're thirsty. You ever been really thirsty? When you are seeking that water, it's like there's nothing else in the world that could possibly be as important. And there isn't, right? Thirst is so critical. But once you've reached your satiation of rehydrating, once you've been very thirsty, you don't have the drive to drink more. In fact, you have the opposite of that, which is the drive not to drink. From a social standpoint, Maslow was very helpful in creating what he called the hierarchy of needs. Right? You start off thinking about food, water, shelter. I like that show Alone. These people have to go out and stay out in the wilderness. Whoever stays out the longest in this last season gets $250,000. I mean, that's a lot of money, you know? And so these people are motivated. They're motivated to get that money. But when they get out there, their motivations change. Their motivations go from, I'm really seeking money, so I'm going to participate in this show, to, I'm actually needing to survive. There are predators out here that will get me. I need to seek out my food source. I need to find shelter and water. And those things become much more important for them to get satisfied first than their need for that $250,000. But what's really interesting, and why Alone is so applicable to Maslow's hierarchy of needs, is that initially there's this need for satiating all those basic level needs of food, water, shelter. But then safety, right? Safety from the predators. And then belongingness. You hear them talk about, I want to commune with nature. I want to be a part of this environment. I don't want to just come in and take from it. I want to be a part of it. And creativity comes in there a bit, which is, you'll see these people. I remember one guy made a chess set. He whittled out a chess set. Another one did really funny videos. He kind of shot like a little bit of a comic version of himself there. And those needs come in for being recognized in what Maslow called esteem needs, or you need to be seen as worthy and someone to be looked at as a model for current behaviors. So that's where Maslow thought was most people's sort of end, was to just be esteemed by their colleagues. He also said that there's a rare set of people, and in fact this is the group he studied. The group he studied were highly successful folks. Most of the people before him, Freud with his neurotic patients, Jung with his psychotic patients, all those folks before Maslow had really looked at pathology, psychopathology, or what was going wrong with people. Whereas when Maslow started, he basically started by saying, I want to search out the most successful people that there are. And I want to look at what are the commonalities that they share with each other, and how can I make that something that people could focus on? How could I understand why some people are so successful and others are not? Finally, there's the self-actualization. And self-actualization is this idea that he wrote about, which was really this sort of peak experience of people being in the right place at the right time with the right training, the right motivation, the right preparedness, where they are fulfilling all that they could possibly fulfill. And he said very, very few people, 1% of people ever get to that level of functioning. That all the rest of us are down here trying to make sure we have enough food, enough water, safety, comfort, friendship, belonging, esteem. Very few of us ever get up to that peak of that pyramid of his hierarchy of needs, which is self-actualization. But the maniacal seeking of that can be problematic, as we see in these people who gain fame and notoriety. Pride comes before the fall, right? So that self-transcendence, if you're seeking that, that shouldn't be something you're seeking. It should be something maybe other people would say about you. You're self-actualized. You're doing the best you could. I think of people like Malala Yousafzai, and I think that woman is a self-transcendent, right? She is a being beyond. She underwent suffering, despite opposition, insane amounts of people trying to firebomb her school, throw acid on people that went to school with her, targeting her as a woman. Child at the time shot her in the head, and she was unshaken. She was motivated to continue to bring more opportunities for young girls to complete education. She saw that as a way to serve her community beyond herself. Despite all that opposition, she didn't give up. So you think of people like her. So that's Maslow, and his theory of motivation is that we want to achieve, our best lives now, for lack of a better colloquial phrase. Let's talk about hunger. What makes us hungry? What makes us pursue food? And how we regulate our intake of food. Your body was designed to store up excessive calories as fat and to burn them in times of privation. Food markets full of food, we've outgrown our need for that ability, and it's become a real detriment to human thriving, which is obesity, where we store too much caloric energy as fat in our cells. We don't expend it. So we build up a big reserve when there's really no marketplace where we could spend it, right? There's no starvation happening for us, and so our fat cells never get utilized, and then they begin to start a cascade of problems where they overwork our heart, they clog our arteries, they cause us to have problems with hormone secretion, they make us less able to metabolize food through having weakened muscle, make us less able to move, all sorts of problems with obesity. Why do we eat? Why do you eat? It's a complex issue that is psychological by its very nature, but let's look at the biological part. Your body has this fat cells, and fat cells are useful for us in that they are the storage of energies that we can burn through to provide us with heat and our ability to move our muscle. Inside fat cells and inside some connective or adipose tissue is a hormone called leptin, and leptin tells a part of your brain, the lateral portion of your hypothalamus, whether or not you have sufficient body fat for the particular context you're in. If anybody noticed, when you stop being as active, stop going out and doing stuff, you start to gain weight. Now we're sitting at home, now we're eating and eating and eating, and our body stores that excessive caloric intake as fat. Also, we're stressed, right? This is a scary time. We don't know what's happening. We don't know who to trust. Fake news everywhere. Bad leadership on both sides. We're in a real world of hurt, and so what that does is it causes us stress, and we'll see how stress affects us in a later chapter. But let me tell you this, it tells your body you're in absolute war mode, and in war mode you've got to store up the best assets for privation, and that is to convert excess calories immediately into fat cells so that you can store that for later when you might not have access to food. From an evolutionary standpoint, as we evolved to have fat storage for ourselves, it was an absolute boon to humans. We are able to crisscross the globe. We inhabit the whole globe. We're ubiquitous everywhere in the world. And we were able to do that because we could travel. We could have storage of fat. We could take privation over a long period of time where we didn't need to have all this food on board. We could go to new sources of food if our food where we were ran out. From an evolutionary standpoint, it totally benefited us. Now that we've solved the food shortage problem, it's causing us massive problems. The leptin in our fat cells, the fatty parts of your tissue, And the adipose tissues, that's the other connective tissue inside your body, they have leptin, and the leptin tells the brain constantly how much fat storage you got. It's monitoring it. And so it's sort of a long-term strategy for your body to maintain that amount of storage. Your brain is telling you to eat something by a couple of things. One of them is an empty stomach. If you have an empty stomach, then it's smaller, right? So your stomach expands with the food you put in. But when you have an empty stomach, it's smaller. And with an empty stomach, the stomach releases another hormone called ghrelin. Ghrelin increases its release the longer you are without food. And this is something that we all have experienced before, where we get a growly stomach. My grandmother was a diabetic, and she would get hypoglycemic. She would act almost like she was drunk, because the brain doesn't have sufficient sugar in it to be doing its activities, and so you lose brain power. You become cognitively impaired for a portion until you fix that by eating foods. Now, the hypothalamus releases a chemical to initiate your eating behavior called orexin. And then you eat food, right? So I'm feeling hungry, haven't had food, so I got my Cheez-Its here. I just snagged these from my kid who was eating them on the couch. So orexin is telling my lateral hypothalamus, remember we have the lateral portion of our hypothalamus, and it's saying you're hungry, right? My stomach's feeling it. The ghrelin in my stomach's increasing because it's empty right now. I haven't eaten since breakfast, and so I take in some calories. I don't even know what these are. So basically, I'm eating wheat. My body will break that down, fills up my stomach, and my stomach will slowly release it into my intestines. Now my intestines, the first part of them past your stomach is your jejunum and your duodenum. And those parts initiate this process of, I take all this food, I chew on it. Mastication breaks it down into small bits. Goes through my esophagus, down into my stomach, through my pyloric sphincter, and then it sits in a pool of acid in your stomach. Your stomach actually has acid in it. That breaks all of the bonds that are in this wheat flour, and they have the potential for energy. Now, they get in to my bloodstream in the duodenum and the jejunum, in that initial part of the small intestine, and then it spends hours and hours and hours weaving its way through the yards and yards and yards of my innards, my small intestines, and all that time, your small intestines are really vascularized. There's lots of blood vessels that go in there, and so the blood is coming in and grabbing little bits of those nutrients and then putting it into the blood, titrating the blood with that. You have a pancreas, which is a different part of your endocrine system, a gland, and its job, again, in this sort of loop feedback of the orexin causing you to eat and your stomach expansion, decreasing or increasing the amount of ghrelin, and long term the leptin, the body fat signaling about how much food you have as excess storage in case of privation and starvation. This whole system is in response, and your brain needs a certain titration or a certain chemical balance of, I hate to use the word chemical balance because you guys think that means that somebody's mentally ill. We'll get to that in the end of the class, but right now there's no such thing as a chemical imbalance. There is something where my homeostatic level of blood sugar, which should be at 80 to 100 if you measure with like one of those little blood finger stick deals, my blood glucose level should be between 80 to 100, 120. If it's lower than 80 or it's higher than 120, I'm either hypo is low blood sugar, or hyperglycemic. And that feedback's going to continue. My pancreas should release insulin to monitor it in between those levels. So what it's attempting to do is to achieve a state of homeostasis where always my blood glucose level remains within this Goldilocks zone, this happy zone for my brain, for my body to be able to produce the types of behaviors that are beneficial. So that's why hunger happens. What's interesting is that you eat 2/3, right? So here's 3 little Cheez-Its. Now, if I eat these 3 Cheez-Its right now, 2 out of the 3, all that the calories that I'm taking in, all they do is keep my body warm. See, my temperature has to stay at this sort of 37 degrees Celsius, 98.6 degrees Fahrenheit for the Imperials out there. We have to stay at that same homeostatic level for temperature for my body to be ready to go at any point. Now, we talked about with sleep that our body does reduce our temperature at night. But that also is when I'm not eating anything. I'm not putting any food in. So it needs less food intake. That's why we don't eat over the 8 hours that we sleep at night, the third of our life that we spend asleep. You don't need food intake because your body's not moving very much. Very little, in fact, when you sleep. You're not breathing as much. You're not pumping as much blood. Your heart rate reduces. And so all these things are in relationship to how much food intake we need and the balance of leptin, orexin, insulin, and how our hypothalamus, lateral hypothalamus, makes us eat. Scientists have messed with people's lateral hypothalamuses. Not people, but rats. And it's interesting. What you can do, if you lesion it, it gets to acting too fast. Or if you cut it out, it doesn't send any signals at all. So you can either turn it up or turn it down. When they do this to rats, either lesion it or ablation, which is to cut out the lateral hypothalamus, these rats do crazy behaviors. They either will eat themselves until they can't even move, right? They just keep eating and keep eating and keep eating and keep eating, or they're never motivated to eat. If you have a brain cancer that was in your hypothalamus and you started to eat and eat and eat and eat, whereas you didn't before, or you never started to eat and you had no motivation to eat, it might indicate to a neurologist where that cancerous tumor is. Although if it's that big for people, then it'd be bad for you. So hopefully that never happens. But we know when we lesion it in animals and when we cut it out of animals, we see their behaviors are changed through their motivations being reduced, so that they don't have a drive to eat anymore, or they don't have the ability to get that feedback loop, right? If we make them keep eating, they never get that satiation, that ghrelin decrease telling them that they're satiated, that their stomach's full. If they never feel that, then they never stop eating, and that's terrible. So part of the hypothalamus's job is to motivate you for eating. Another part is about temperature. Another part's about water, how much food you need to take in. Another part of the hypothalamus is about fight or flight, which is, again, from Maslow's thing, it's right past food, it's the safety needs. And fight or flight mechanisms are governed by your hypothalamus, which tells you when you should be prepared to run. Right? That's the flight, or to fight.
Madness. This is Sparta!
If you're cornered or something. And so turn on quickly, the sympathetic nervous system is the fight or flight response. So you've got feeding, right? Food and water for the hypothalamus. And this is the 4 F's of the hypothalamus, right? It's for motivating base level human behavior. Feeding behaviors, the 4 F's are feeding, fight or flight, and reproduction. You probably got that last F is a different word that I'm not going to say here. But that's the funny part of, that's the only funny joke in neuroscience, is that the 4 F's of the hypothalamus. But again, for reproductive behaviors, that is where the hypothalamus, a different part, not the lateral portion, I believe it's the inferior portion of the hypothalamus. If we go in and we mess with the inferior portion by cutting it out in certain animals or by lesioning it in these rats, we find rats, their sexual behavior, their reproductive behavior gets completely awry. Let's say you take a male rat in its prime, unaltered, still has its testicles, and you alter its hypothalamus. That rat, which in any situation where it finds a female rat in estrus, that's when female rats, unlike females, they signal both estrus and ovulation is at the same time as menstruation. So the male rat knows she's ready to engage in sexual behavior, and that it will, I don't know if they know it like we know it, but they're motivated for it. If you cut that part out of the hypothalamus of the rat, this female rat in estrus walks up to him. She's looking, I don't know who the hot ladies are at this time, but she's looking like a really hot female rat. Walks right by him, puts her little butt up in the air. That's called the lordotic posture, where they present their vulva, and this is a normal mammalian behavior and mating behavior. He doesn't pay two minds to it. He's just, whatever, I see you, got no interest. Now, that's crazy, because what you've done is you've shown that just a small portion, the hypothalamus, the below thalamus, is in charge of motivating us for these very evolutionary important behaviors. And the same thing is true when we cut the lateral sides out. The very evolutionary important behavior of eating is messed up if you screw around with the hypothalamus. Also, you can alter that the other way. You can lesion it and make that part very, very active, in which case animals will pursue mating with even like non-other animals. They like hump objects in their cage. They're highly sexed. It's very strange. But that's all related to the hypothalamus. You have a part of your brain that's regulating when you should be pursuing these things and getting a feedback loop. Notice that when you do pursue that water, right, go for a big run and you get very dehydrated, when you drink all that water, you're satiated and the drive is reduced. That's that drive reduction theory. Similarly, sexually, right? If you were sexually motivated and then you achieve satisfaction that way and satiation that way, you don't immediately want to have sex next. And that's drive reduction, right? Maybe later, but immediately afterwards, you're not as motivated to, because that need has been satiated. So that's where we see the sort of feedback loop between our hypothalamus and our body on these important reproductive and physiological, biological behaviors. Okay, let's talk about emotions. Emotions are something that's imperative for human beings. Partly because we're ultra-social creatures, but partly because this world's too big and complex for us to know everything on a logical level and be able to make perfect discerning judgments on base rates, right? I love stats, and I always say we should live our life based on statistics, but nature, God or evolution or whatever did this, imbued us with the ability to make emotional judgments and learn from them to sort of pursue a sense of well-being, human thriving, for lack of a better term, happiness. Contentment is probably a much greater pursuit than the latter word, happiness, which has just been bastardized to mean just whatever you want to happen, sort of your fantasy of how you want life to go. That's not what emotions are about, is helping us to do. Emotions can be judged in terms of their intensity, whether it's high arousal, meaning that our central nervous system is freaking out, or it's low arousal, where it really drives down our biological functioning. Whether we find it pleasant, something that's good, for lack of a better word, or something that's unpleasant, bad, right? So high good or low good, high bad or low bad, these are different valences or a value for a particular word. In fact, our words that we use to describe emotions give a sense of both the arousal level and the pleasantness of what we're experiencing. If I said, I'm feeling distressed, that might be something where you're like, ooh, that person's having a bad experience, unpleasant experience, and it's kind of like moderate level. If I said I'm terrified, that's high arousal and bad. If I said I'm ecstatic, that's high arousal, but it's good. It's a pleasant thing. If I say that I'm really sleepy, right, that's low arousal and bad. If I say I am content, that's low arousal and good. So these words that we use for emotions really give a sense for other people to understand where we are on the arousal level and where we are on this sort of valence level of good versus bad. How do we value this what's happening to us in our experiences? People have tried to understand how our physiological arousal and our subjective emotional experiences coincide. William James, remember him, the father of American psychology, he believed that first you have the stimulation. You know, a tiger walks into the room. Your pupils dilate, your iris dilates, your heart rate starts to increase, you start to sweat, your sympathetic nervous system is really highly aroused, and then you feel fear. So that's what he believed, is that then you feel fear. Whereas Canon Bayard came along, this is a separate theory about emotions, and said that you actually feel the emotion at the same time the arousal is happening. It's almost like there's two separate systems. One is your subjective experience, and one is your biological reaction to this particular stimuli. Schachter and Singer believed that first there's the stimulus, right, the tiger walks into the room, then there's a physiological response, and then your brain has to make a cognitive interpretation of that. And that sort of says we've got to label this feeling, this emotion. Why is my heart racing? Why are my all my sweat glands secreting sweat? And that makes a lot of sense. We label then our emotion after we've sort of seen the stimuli and felt what it's making us feel. I remember going to Yosemite Valley for the first time. I remember experiencing what I would suggest is the emotion of awe or transcendence, standing at the base of El Capitan. I remember looking at it and just having an emotional state that was difficult to describe with words, which I think awe or inspired or transcendent experience or the ways that we would describe it, right? It wasn't a super high level experience, but it was a very positive experience, and it was a unique one that I had not experienced before. When we experience new emotions for the first time, we might not know how to label them. And as we experience those things more and more, we'll get better at describing to other people what it was like for us to experience them. That's another benefit of emotions, is that we can share them with each other, and they can make us intricately tied to one another's experience of this world. For example, you could have your iris dilate, you start sweating a little bit, your heart rate could increase. You might be ready to speak in public, or you might be ready to have sex. You might be also fearful about starting a new job, and all those, the same biological experience is happening, right? This central nervous system increase in activity, but the context of each of those are different. And so the context is what gives you a sense of, how do I label this? I label this one fearful. I label this one exciting. I label this one fearful and exciting. And so that's where I like Schachter and Singer's model of emotions. The next thing we're going to talk about is the universality of emotion. It turns out that when things are universal, it means it has to have some form of biological connectivity, right? Because we're all the same species. Everyone in the world is the same species. We have vastly diverse contexts in which we've experienced life. Think of a child laborer in Bangladesh, and think of Kanye and Kim's kid, Northwest, growing up on billionaire parents and in a beautiful farm in Wyoming and living in the hills, right? Very different context for those two people. And yet, the way we express our emotions to each other physically is something that's universally discernible. Whenever you see someone who has a face of, you see excitement. Whenever you hear or you see contentment and happiness. Whenever you hear or see, it's anger or aggression, right? We have universal emotions. You don't need to have experienced that person's cultural context to understand what they're experiencing when they give you that sort of look. Disgust, right? Everywhere. We have the same recoiling. Our head recoils. We scrunch it up. We close. We squint our eyes. It's universal when we're we're disgusted by different things, right? Some cultures are disgusted by some things, and other cultures aren't disgusted by that particular thing at all. But we all express our internal experience of disgust the same way. Children who are born blind, they learn to smile. How do they express their emotion of joy if it's not an innate thing, right? They have never seen their parents smile. They visually can't see that, right? So they couldn't model it. When we smile, we don't like put our kids' hands on our mouth or something. They don't have an experience of it. So it's an innate human thing to express the internal state of your emotions. That's universal, right? We are all connected. We are all one species. And we've evolved to express our emotions the same across all cultures. We don't know across all time, but I would suspect that it was something that was so beneficial for us as the ultra-social species from an evolutionary standpoint that those people that didn't express their emotions well actually didn't get to reproduce as much. What will be interesting is now we have an entire group of people who's increasing in numbers, autistic people, who don't express emotions and don't interpret emotions well interpersonally between each other. It'd be very interesting to see what are the base rates of reproduction for those folks, and is it an impediment to them to pass on their genes? And this will be a question that a lot of people will be asking hundreds of years from now, is what element of understanding emotions, being able to express emotions, and the universality of expression of emotions had to do with human survival and thriving. Sometimes you don't feel like you want to. And I'm going to tell you what people told me when I was struggling as a teenager in situations to withhold my expression of emotion in a place where I shouldn't be expressing it. They said, fake it till you make it. If you don't feel happy, act happy until you start feeling happy. If you're at a funeral and you don't feel sad, act sad until you feel that sadness. That's because it's the appropriate social thing to do. And there's actually science to prove this. So really interesting research that was done was taking people reading comic strips, like the funnies in the newspaper where you get the Peanuts cartoon but you get a cartoon, you read these little strip cartoons with some dialogue, and you think, Far Side is a classic one. I love Far Side cartoons. You think, oh, that's really funny. Sometimes it makes you belly laugh, and sometimes you're like, that wasn't even hilarious at all. So there's variability in how funny we think certain cartoons are. Researchers took half of a group of people and told them, we want you to hold a pencil. I don't have a pencil with me, but hold the pencil in your teeth. So you'd bite that pencil and then hold it in your teeth. Okay? So if you do it like that, then they would have you read these funny cartoons with the pencil in your mouth, right? So your facial structure is the same way the whole time. Sorry, you probably can't hear me. Your facial structure is the same way the whole time while you're reading these comics, and at the end of it, they ask you to take that pencil and to write down how funny you thought those comics were, I don't know, scale of 1 to 10. But the other group, they were told, put the pencil in your lips and hold it in your lips. So you're using a different set of muscles, facial muscles, to do these two things. If you hold it in your lips, what you're doing is you're engaging muscles that are similarly engaged when we frown. Whereas if you hold it in your teeth, you're engaging those muscles of a smile. The group that held it in their lips, they're enacting that frowning motion. They rated the cartoons as statistically significantly less funny. The same cartoons should be equal groups. The only difference is how their facial structure, the musculature of their face, is. The group that held it in their teeth significantly rated it as funnier. Same cartoon, same stimulus. So what we have here is a situation that our physical manifestation of an emotion we think comes after. But in fact, you can manifest that physical outcome of the emotion before you feel the particular setting. This lends some credit to those theories about emotions, the James Lang, the Cannon Baird, the Schachter Singer. And it's really an important distinction to make sure that we understand our emotions are valuable to us. What they do is they guide us in decision making about where we should go and what we should do, and if what we did had a good, successful outcome, right? These emotions and our memories about these emotions are going to help guide us. So that's why motivation and emotion is a part of this psychology class. I hope you guys enjoyed reading this chapter on emotion, and I look forward to hearing your stories about funny and scary things that happened to you and how you experienced them, and whether or not you think that first what happened was your physiological arousal, or first what happened is your experience of that particular emotion.